Good morning, GIS 300, and welcome to week number 5. You may already know that in your great and good state of Maine, you can go to your Maine Department of Inland Fisheries and Wildlife and access the harvest information by year for bear, deer, moose, and wild turkey. Clicking upon the harvest report for 2019, we can access some information there and a map here. Zooming in, we can see a count by town. And your state's biologist will provide these information in spreadsheet form to your professor for educational purposes. And that is what you have here. So bear 2019, deer 2019, and moose 2020. So this is an imperfect comparison. We have 2019 and 2020. Just have to keep that in mind. Opening up one of these spreadsheets, this is bear 2019 by town, and the town is listed by Geo Code. You'll remember from last week the joy that we had of matching the names to the names. Using the Geo Code avoids the issues of is it St. John Plantation or St. John Township or something to that effect, or misspellings or different ways. Do you spell out township? Do you just write TWP? That kind of a thing. The Geo Code gets you around that issue. But we need to have the Geo Code data to start with. So search for Maine GeoLibrary Data Catalog. You've been here before. Maine.gov, MIGIS catalog, however you want to say it, and that takes you here. You have all these available data sets, but we want to scroll down to Boundaries and Maine Town and Townships Polygon. Click there, and here it will show you all of the attributes that you have, and among them is the geocode. And you see the preview of the data here, so go ahead and download and select Shapefile. The result is a zipped file in your Downloads folder, which you can extract. However, you do that on a Mac as well. Browse to your location, and I'm going to pop that into week 5, select folder, extract, and there it is. Now I've gone into my week number 4 demo and just made this week number 5. So project, save as, save week 5. So now I have 3, 4, 5 all in a row using a lot of the same data sets, and we will use the roads and the census data for this one. But to start out, we need to bring in those 4 data sets. So we have 1 spatial layer, 1 shapefile, and 3 tabular layers, 3 spreadsheets. And those I've stored in week 5 data. Suggest you do about the same. And here I want to bring in the SHP, so just double click on that. There it is. Big yellow blob there. Right click, zoom to layer. There is the great and good state of Maine. And likewise with all these spreadsheets. So just double click, double click, double click, and they are all here now. If we want to look at them, we can right click and open attribute table, count moose. 3170, count 7. Let's open up the deer and take a look at what we have there. Open attribute table, geocode. This one has the town name for reference, really. And then we have adult male, adult female, fawn female. It doesn't say deer, but we just have to remember when it says adult, fawn, we're talking about deer. And finally, let's take a look at the bear. So open the attribute table, count bear. And to be clear, every one of these is a self-reported location of where a bear, deer, or moose was killed, reported by a hunter. It is possible that somebody misreported data, so they might be in township T10R9 and report T9R10. There's no way to verify that, unfortunately. We just have to accept that that is a potential flaw in the dataset. So flipping digits like that, taking a T10R9 and reporting T9R10, that's a transposing error, where you've flipped numbers. That could be considered an innocent mistake. But if you draw a tag for a bull moose in zone 1 and shoot one in zone 2 and report it as being in zone 1, that's not an innocent mistake, that's poaching. In any case, let's take a look at some of these data. So we need to bring in, or we already have brought in, the Maine Boundaries Town and Townships Polygon, which is this one we're looking at here. And remember how to do a tabular join from last time. Right click, Properties. Properties, Joins, and then the plus sign to add a new join. Let's go ahead and start in this order, so moose, then deer, then bear. And we have to do them all one at a time. So we have alphabetical listing here, moose, join field geocode, target field geocode. Okay, let's see how that worked. Okay, right click, open the attribute table. We have Geo Code and Geo Code number, and I'm guessing that's just a text format versus a number format. The numbers all seem to be the same. So going all the way to the right, we have town code moose kill, null, 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 1. So not every town has moose killed in it. So let's go ahead and close that and take a look. So double click or right click properties, symbology, and then graduated instead of single symbol here. And the value is going to be the count moose. And let's go ahead and classify that into the quantile here and go ahead and hit apply. So we can see here, these are the towns that have at least one moose killed in them. And if it's blank, there's no data, therefore no moose killed, or at least no moose reported killed. Now last week we talked about how sometimes the software likes to crash if you try to do too much with a joined layer because it's holding all that in its memory. That just happened. Software just crashed, I had to restart, now we're rebuilding. So 2 lessons, 1, save often, and 2, right click, export, save feature as. So instead of being a joined layer, it's a permanently saved layer with all the information in the attribute table. Before I do that, I want to make sure I get all 3 of these joins done, so I just have to do it once. So back we go, right click properties, into the joins, there's no joins because it crashed, and let's go ahead and just go moose, deer, bear again. So in alphabetical order we have moose, we have geocode, we have geocode, okay. Do another one, we have, next one down is the deer. And the join field is the geocode and geocode, okay. And now we got the bear. And the bears are already selected there, join field, geocode, target field, geocode. So again, we have the same geocode in both of those and we're using those to stitch those together. Okay, so now we have all 3. Okay. Let's go ahead and look at our attribute table. All the way to the right, we have all of the information for the adult and fawn deer. And then we have, let's see, there's the count moose. And here is our count bear. So I'm going to close that before it crashes. Right click, export, save feature as. And I need to go into the browse here. And I'm going to save that in my week 5 and call that towns bear moose deer.shp save. Okay. And coming back 10 minutes later after fixing a minor data issue that not important enough to go into because I fixed it, you won't have to do it. There was just some old stuff in the spreadsheet that the biologist sent that didn't go well into the GIS. So I'd make sure it was just only those data and not other notes and other things they had that confused the software. So now that we have this, we can right click, go to properties, and see there's no joins here. Those tables that I joined in have become a permanent part of the attribute table. So it's no longer considered joined. It's now just one finalized permanent thing. So there's no relationship between 2 different layers, or 4 different layers in this case. It is just one layer that has those attributes permanently associated now. So now we can go to symbology and we can select graduated and select our value. We have options for moose, deer 1, 2, 3, and 4, and then bear. So let's start with a moose and use equal count quantile, classify, apply. See, the reason it doesn't look like it did before is I still have this other layer turned on underneath, so that shows through, but there's no data for moose down here because no moose were reported killed. So we have deer 1, 2, 3, and 4. For whatever reason, maybe this was too long, probably exactly what was going on there, but we have these 4 categories numbered. So let's go ahead and just make sure that the town of Abbott 21010 has 43 in deer 1 for that column. Make sure those are in order. So go 4391 for the town of Abbott. So let's go ahead and close that, open up our attribute table here, sort by town. Abbott is here. all the way over here, deer 143,910. So those are in the same order. And now what if I want a total? Of course I want a total. So let's go ahead and deselect all features, because sometimes when you have something selected, it goes that way. So let's go ahead and use our open field calculator. We want to create a new field that is called deer total, and that is going to be deer 2019 1 plus deer 2019 2 plus deer 2019 3 plus deer 2019 4. So that's just going to sum all those up into one total. So we have the total number of deer harvested in each town for each year. So see, that just adds up all that. So now we have deer total, which is comparable to bear total and moose total. Now with that done, we can right click and duplicate the layer, because I would like to show two of them. I'm actually going to move the copy up above here. And remember, these layers, these are not data sets. These are instructions for how to access the data set. And you see here where it's stored. It's an instruction of where to access the data set and how to display it. And we can display that same data set in any number of ways. And you see I've changed these names here, which you do by right click, rename layer, and you just type in whatever you want. So I've called that Deer Harvest 2020 Total. And now we have to make that so, because it's still displaying the same moose data. So double click, symbology, and let's change that to deer total. And let's go ahead and use the same color ramp. Remember, we have to classify. So maybe we don't want the same color ramp actually. Let's see if we can go blues for the deer and apply. And we notice a very different trend. Isn't that interesting? So we can actually set some transparency on this whole layer. Let's go ahead and do that. That is under layer rendering, and we can set the opacity here. Let's apply that. And that way we can kind of see if there's something going on underneath with a different layer. There's not with these two data sets. There's quite a lot of separation between them. But let's go ahead and set some transparency on our moose harvest as well. Okay, so now we can see there's actually some overlap here. We'd have to look closer at this township here, and there's some moose, but it looks like it's a better spot for deer. And of course we can use our identify features tool with moose harvest selected and find out that in 2020 we had a total of, let's see, 3 moose. And since it's all looking at the same data set, we have 66 deer. So 66 deer in 2019 to 3 moose in 2020. Of course, that's not apples to apples, it's different years, but it's still quite a difference. Before we move on to the bear data, I have to show you one thing that's gotten in the way of doing this the quick and easy way. And that is the Geo Code. The Geo Code is 1, 2, 3, 4, 5 digits. But if you go into Excel, sometimes it'll treat that as, oh, that doesn't need to be there, that's a 0. Numbers don't start with 0, numbers start with a 1 through a 9. Well, when it's an identification code like that, you've got to have the 0. So everything that started with a 0 no longer shows up on the map because those don't match. So I need to fix that. By the time this data set gets to you, that'll be fixed. You don't have to worry about it. But for your knowledge and education, because that's what we're all here for, your edification, edumacation, getting your wickets mat. When you are trying to match two things, sometimes it's important to make that a 0. And the way to fix that is to go into the Excel. And in the Excel, we are going to create a new column called Geo Code 1, or I might as well call it Geo Code 0 because we're adding zeros. And that's going to equal concatenate. Click there if we can't spell it. And that is going to be quote 0, quote, comma, cell A2. And that's going to add a 0 in front of whatever's in cell A2. So now we have all that, but we don't want to go for all of these because not all of these have that problem. So we have to go down, 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 down until we get through the 7,000s, the 9,000s, and once it's well over 9,000, we got to stop. And then it's just got to go equals that. And that carries on down forever. Now I'm going to take that, I'm going to copy it, and I'm going to call that a text column. And that's going to be Geo Code 1 now. Right click, or just, no, it doesn't let me do that. Copy. And paste 1, 2, 3 value. So you see how this switches formats from, where was it? From here to here. Now it's all the same format. So now that's pasted in. Now I can delete that. I can delete that. And now I can just go ahead and say here, this is all text. That's fine and good. It's giving me these warnings here. Number stored as text. Yes, that's exactly what I want. Thank you very much. Geocode 0. So now that is all good. I can hit save. I'll redo that join. And I'm just going to call that Geocode itself. Save that again. So when you get to this, it's going to look like this never happened. But for your education, that's what the problem was, and that's the solution. So now we've got that all rebuilt. We can see the deer harvest in 2019, the moose harvest in 2020. And going into the bear, we have the same thing where we have equal counts. 2, 2 to 4, 4 to 6, 6 to 8, 8 to 52. Okay. And let's check that on, and now we have all the townships in Aroostook. It's not really the ideal symbology. Let's go ahead and look at why. So here in the attribute table, we have the bear total, and we can see that we have a few towns that have an awful lot, and then it quickly declines. And part of the issue that we're having with this data set is that we have a lot of different parts to the same township. So Cherryfield is in here 1, 2, 3, 4, 5, 6, 7, 8 times. And then again up here. So because it's displaying by total here, this is all messed up. So we need to change this. This has got to be fixed. And this is why I normally work with that other townships layer, because when we look, especially at these coastal towns, every one of these is a part. Every one of these has a row in the attribute table. There's a quick way to fix this. That is to go under Vector, Geoprocessing, Dissolve. And we need to have a dissolve field, and let's go ahead and use the Geo Code because that's what we're using for our join field as well. So that's going to take all those different parts and combine them into one row. And that row is going to have all the same data, and that's going to fix the issue we're having where some of these towns have upwards of 20 parts to them. And that changes how all of this is displayed. So let's go ahead and hit our back button here, and we want to save that. So save to file. That file type is going to be a shape file. And let's call that main deer bear moose dissolved.shp. And if it's not type shp, go ahead and find that right under there, save and run. And we have some invalid geometry warnings, has been skipped. That should be just fine. That is almost definitely just fine. But let's go ahead and see if it makes any difference, because sometimes with all these little things going on, it just goes weird. So let's uncheck those, right click, zoom to layer up at the top. Looks like that part of the state of main is still there, very good. And let's compare. So checking on the old and off, we see that we're missing some little bits around Moosehead Lake here. And that I don't expect to make any difference at all. So it is good to check. But sometimes you just get those kinds of slivers and it throws an exception like that. And as long as you check on it and it's still good, then you should be fine. But let's go ahead and check on that right there. So we can use our Identify Features tool. Which one was it? Right there. Check on that. Geo Code 29250 Jones port. So I don't know why that didn't work. We have data here, but basically we're saying, oh well, and move on for now. That is not an important part here. And if we uncheck that, go away, and then select from here, we have Jonesport. We have the same data, everything's good. So for whatever reason, that part of the ocean, that's what that is, that's not actually land, so we simply don't miss it. Now, I don't like having all this stuff here, all this extra stuff that's not land. So I'm going to actually go ahead and do one more step here, and I suggest you do the same. And I'm going to clip this to my main 24 townships to shorelines because I just don't want to see all this stuff that's accounted for, but not actually land. I want to see, well, deer live on land, moose live on land, they sometimes swim, but I want to see just that. So I'm going to go vector, geoprocessing, clip. I'm going to save the input layer as the dissolved here, and I'm going to use the overlay layer, which is the one we've been using before, which is the townships to shorelines. And I'm going to go ahead and save to file again, and I'm going to just add on the end here to shorelines.shp, run, wait, no spatial index exists for input layer Y. So what I do when I get an error like that is I paste it into the Google, and usually something comes up like this. And I've gone ahead and clicked on this, and then I've done a Control F for that same text within here. That's the text. Scrolling up to here, we have an explanation for what's going on. Where did it go? I just saw this thing. Oh, where did you go? There it is. So when you ran your model, you may have noticed a warning message. No spatial index exists for the input layer. Performance will be severely degraded. Reasons why. In summary, you can of course read if you want to, but the long and the short of it is that it speeds things up. So it's not going to not work, it's just going to take longer to work. And here we are, so I'm going to go get a snack now. Bye. There we go. One snack later, we have a clipped layer. And we've got to drag that all the way up to the top so we can see it. There it is. Very good. So now every one of those is one part, and now we can redo our symbology so we can see more accurately where the deer were harvested. And the bear and the moose as well. So now we have our bear, our deer, and our moose. And now we can see some patterns in the deer data, and we can see that this broadly reflects the population. Where there is the deer, and that's the key for the deer. And let's uncheck that, and there's the population. Now I had been thinking to have you do a statistical analysis of whether there's a correlation between the population and the number of deer harvested, but I'm sure some of you have Excel, some of you don't, some of you would have to use Google Sheets. Google Sheets can't accept the data straight out of here. I think that would just be a mess. So let's do something else. So what I'd like to see is the number of deer per square mile, or the number of deer harvested per square mile. That means you're going to have to calculate the area of each town in square miles and divide the number of deer harvested by the area. Now let's have a reminder how to do that. So right click, open the attribute table, and go into the open field calculator here. Remember that is $ lowercase area, where that $area gets you the area in the units of the coordinate system, which is square meters. You then have to multiply by a conversion factor, so that's the asterisk, and then paste in that conversion factor, which to get from square meters to square miles is 0.000000. So 1, 2, 3, 4, 5, 6 zeros, then 3, 8, 6, 1, 0, 2, 1, 5, 8, 5, 5. And I strongly recommend you Google square meters to square miles and just paste that in. So now we can go ahead and hit, well, first I have to give it a name, that is square miles, and now we can hit OK. And let's go on over here. We have a number of square miles, and we see we have an error here where these are all round numbers. We didn't want integer type, that's an oops. Let's do it again. So now we have square underscore miles, and we don't want an integer, we want a real decimal number, and we want, again, $area times the asterisk, our conversion factor. Okay. A standard survey township is 36 square miles, and there are often variations on that, so these numbers make sense. This looks like it's where it ought to be. But let's see, good old Rumford there is looking like 70 square miles, or as the case may be, 69.849. And is that a bit bigger than a normal survey township? Yes, it looks like it is, so there you go. So it looks like we've done that math right. Let's go ahead and go back into the attribute table and do our last bit of math here. Last bit of math for now. And into our field calculator, and that is going to be the deer total divided by square underscore miles. And we are going to call that a decimal number, real. And that is going to be deer underscore square miles. Okay. Now all the way to the right here, deer square miles. That's the number of deer harvested per square mile. Close that. I'm going to right click and toggle the editing. Save. That saves what we just made. And now I'm going to right click and duplicate the layer because I want to keep that old symbology. Oop. Nope. There we go. Now I want to change this, so instead of the total number of deer, I want to see symbology. Deer total. I want to see deer per square mile. Classify. Okay. And now check that on. It changes a little bit, doesn't it? And now remember up here we have properties, and let's go ahead and instead of, well no, we've already got that where we want it, so we have that in quantile, equal count, and that's essentially ranking these townships. So we have 1, 2, 3, 4, 5 quantiles. Each one of those is going to have an equal number of townships within it. So that's sort of an apples to apples comparison. Where here we have our deer, equal count quantile, 1, 2, 3, 4, 5 categories. Okay, so there should be an equal number of towns with the same color, but which towns those are seems to change. So keep an eye here. This one is in the top category of deer per square mile, but not in the top category of deer overall. And of course, that's because it's a small town. So if you take 10 deer from a small town, that's a very different story from taking 10 deer from the town of Allagash. Allagash being more or less 4 townships put together, where each one of these is much smaller than a full township. And of course, we have the city of Portland, which is not, in fact, water. It's just a place where you can't shoot deer. So for this part of the assignment, you're going to be making 6 maps. 1 each for each of the deer, bear, and moose, and then 1 each for the deer, bear, and moose per square mile. So you're going to do what we just did for the deer, the bear, and the moose individually. Maps are to show scale bar, legend, north arrow, just like last week.